Hi everyone, welcome back to the session. Very good morning. Am I audible to all of you?
Yes,
Yes,
sir.
sir.
Yes, sir.
So yeah, in the last class we were discussing about the native application, and I hope I have given the notes of native application, and we stopped in the advantage section, right? So now you write on a heading: advantages of native application. Advantages of native application. Under that, point number one. Point number one: the performance of the native application will be very fast. The performance of a native application will be very fast. The performance of the native application will be very fast because 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 a separate code has been developed for a particular device, because separate code has been developed for separate code has been developed for a particular device OS, operating system, particular device OS operating system. Okay, next, better use of, second point, the better usage of OS and the device specific functionalities. The better usage of OS and the device specific functionalities. The better use of OS and the device specific functionalities. Next, third point. There will be a good interactive UI and UX, user interface and user design. There will be a good interactive user interface and user experience, UI UX. Fourth point, lesser compatibility issues, lesser compatibility issues, lesser compatibility issues, and faster to configure, and faster to configure. Lesser compatibility issues and faster to configure. Next, disadvantages. Disadvantages of native application. Point number one. Building a OS specific app. Building a OS specific apps can be time consuming, because we have to develop for Android, separate for iOS. Building a OS specific app can be time consuming. Second point, OS specific programming languages. OS specific programming languages. OS specific programming languages like Swift and Java are hard to learn. OS specific programming languages like Swift and Java are hard to learn. Hard to learn. Are hard to learn. Look at here, one more point, very, very important. Just see the diagram here. Assume that I am developing an app for Android, and I'm developing an app for iOS. After that, what I'll do, I will go and launch it in the production environment, in the prod. Okay, so for Android, we will use Play Store. We will go and launch. For iOS, we'll use App Store. We will go and launch it here. Okay, so tomorrow when we want to make some changes, we have to develop the changes here, and then we have to do the testing. Once it is stable, same way here also we have to do the development. It has to be stable. We will do the testing, and then at the same time, so Android developer should release it to the Play Store, then iOS developer should release it to the App Store. So it takes long period of time. Assume that this fellow is absent, only this fellow is coming to office for 1 week. That time he cannot directly go and release it to the Play Store. Both has to go on the same time, so they have to wait. And if this fellow is not able to develop, if he's taking more time, this fellow has to wait more time. So longer release cycle to ensure the stability of an application. Right on. Third point. Longer release cycles to ensure the stability of an application. Longer release cycles to ensure the stability of an application. To ensure the stability of an application. Last point. We have to maintain separate code base for both Android and iOS. We have to maintain separate code base for both Android and iOS. Full stop. When we want to add a new features, to the application, separate code has to be implemented in Android and iOS programs. Separate code has to be implemented in Android and iOS. Example, I have already given example for native application. Next heading, you take hybrid application. Second one, hybrid application. Hybrid application. Hybrid application. Hybrid applications are the combination of native apps and web apps. Look at here. When I want to develop this hybrid application, assume that I don't have that much money. I just started a company. I don't want to invest too much of money for native and iOS because I have to hire separate developer for Android, separate developer for iOS. But now I don't have that much money. So my company is very small and I don't have too many users. That time what they do, they develop hybrid apps. Okay, they will develop one application. To develop this, they will use HTML, CSS, JavaScript. They will use to do the development. They will develop, and the same code will be used for Android, same code will be used for iOS. Means once developer develops this, he will go and put it in the Play Store and he will go put it in the App Store. Same code will be used for both Android as well as iOS. In future, when you want to give any update, you just have to make changes here and he will do the testing and he will deploy it in the Play Store, he will deploy it in the App Store, automatically user will get an update of that application. So this is about hybrid app. But when I say combination of native and web, means here we are using HTML, CSS, JavaScript, plus sometimes if required some Java basics skill, technology and Swift technology, small little bit, not full, little bit required, right? So that time we will be using it. So a single hybrid app will be developed to work on multiple platforms, so that effort will be very less compared to native. But when I compare the speed wise, so this is a little slower compared to native application, because it is developed using HTML, CSS, JavaScript, and sometimes it will not use the device specific features, like some of the camera will not work sometime, contact list will not work sometime, GPS will not work, not all the time, but sometimes you will face an issue with this hybrid apps. Okay, now write down heading hybrid application. Hybrid application. Hybrid applications are the combination of native application and web application, or the combination of native application and web application. Next, hybrid applications are developed. Next point. Hybrid applications are developed using HTML, CSS, and JavaScript. HTML, CSS, and JavaScript. Next point. Third point. A single hybrid app can be developed. A single hybrid app can be developed to work for multiple cross platforms. A single hybrid app. A single hybrid app can be developed. A single hybrid app can be developed to work for multiple cross platform. A single hybrid app can be developed to work for multiple cross platform, which will reduce the development efforts. It reduce the development effort. It reduce the development efforts by overcoming the. It reduce the development efforts by overcoming the need for development of. It reduce the development effort by overcoming the need for developing a separate app. Need for developing a separate app for different devices and OS platforms. Different devices and OS platforms. Okay. Then let's take advantages. Advantages of hybrid app. Point number one, it is easy to build. Point number one, it is easy to build. Easy to build. Point number two, same code can be used for both the platform. Same code can be used for both the platform. Next, third point. The development cost will be very less compared to native application. The development cost will be very less compared to native application. The development cost will be very less compared to native application. Next, fourth point. Easy to push the new features. Easy to push the new features because we are using a single code base. Because we are using a single code base. Fourth point. Fourth point. It takes less time to release it to the market. Wait. Shorter time to the market. Shorter time to the market, which means shorter time to the market, which means a single app can be deployed for multiple operating systems. A single app can be deployed for multiple OS platforms. You can see that. Okay, so then disadvantages of hybrid application. Point number one, if the application is very complex, if the application is very complex, with many functionalities, if the application is very complex with many functionalities, it will slow down the app. It will slow down the app. It will slow down the app. Next, second point, it is more expensive than the web app. Correct? More expensive, correct? I'm not saying native. I'm using a word web. It is more expensive than the web application, not native. I'm using. It is less expensive compared to native, but it is more expensive compared to web application. Right on. It is more expensive than web application. Then third point, it is less interactive compared to native application. It is less interactive compared to native application. Fourth one, sometimes application cannot perform OS specific task. Sometimes hybrid apps cannot perform OS specific tasks. OS specific tasks. Example, you can take a Gmail, or say Instagram, or Twitter. Means when they developed in the beginning time, so when they started, they usually developed a hybrid app. Then over the period of time, they changed it to native. They started maintaining separate code base. You can take Facebook, WhatsApp, Twitter, LinkedIn. So these are all hybrid apps. Now you can ask, sir, is it hybrid apps now? Now it's not hybrid apps. Now it's a native app. But earlier, when they started in the beginning stage of development, they have started with hybrid apps only, because they wanted to see the customer behavior over the period of time. They wanted to grab the customers. Okay, so this is about hybrid apps. Next up, web application. Web applications. Web applications. Web applications are the responsive version of the websites. Web applications are the responsive version of websites. Responsive version of the websites. Responsive version of the websites that can work on that can work on that can work on that can work on any that can work on any mobile device or operating system. That can work on any mobile device or operating system, because they will be delivering the contents through mobile browsers. It can work on any mobile device or OS, because they are delivering the contents using mobile browsers. Completed? Completed, Aura?
Yes, sir.
Yes, sir.
Next point. Web applications or mobile web. See, there are two types. Okay, whenever I talk about web, right, mobile web, or say, I come back here, wait, native hybrid app and web apps. When I say web apps, when I say web apps, when I'm talking about mobile, it is a web. That is mobile web. When I'm talking about a laptop or desktop, that is normal website. That is normal website. When I say web app, it is web, mobile web plus normal website, which is used in the desktop or laptop. But web means in the mobile browser we will be using it. It should be compatible. So we will have an option when we are doing a development. So we have to select web and particularly that web. So then it will deliver the content properly to the mobile browser, so that you will not get any compatibility issues. In the same way for website also, that developer will be knowing it, how to select, what to select, right? Web apps or mobile web apps. Web apps or mobile web apps. You tell me, when you want to open qscircle.com in the browser, are you installing it from the Play Store?
No, sir.
No, sir.
You're not installing, right? Do you
Yes,
require
sir.
separate storage space in your mobile for qscircle.com?
No, sir.
If you don't have an internet, will you be able to open that website?
No, sir.
No, sir.
Internet is mandatory, right? Okay. Now write down. So mobile apps or web apps or mobile web apps, can work across multiple OS browsers. Can work across multiple OS browsers. Can work across multiple OS with the help of with the help of internet. With the help of internet. With the help of internet. Okay. Next point. It does not require any storage space or installation process. It does not require any storage space or installation process. It does not require any storage space or installation process. It does not require any storage space or installation process to use web apps. Next, last point. Web apps can adapt to various screen size and devices easily. Web apps can adapt to various screen sizes and devices easily. And it will work with the help of internet. And it will work with the help of internet. The help of internet. With the help of internet. Okay, so now write down advantages of web apps. Advantages of web apps. Point number 1, it reduces the overall business cost. It reduces the overall business cost. It reduces the overall business cost. Second point, no installation process is required. No installation process is required. No installation process is required. No need to be downloaded or installed. Next point. No need to be, wait, no installation process is required, comma, continuation. Wait, no installation is needed. Keep, put full stop. Don't put comma, put full stop. No installation is needed. Full stop. Okay, we don't have to download it, right? We don't have to download it or install. We don't need to download or install this web apps. We don't have to download or install these web apps because it is working with the help of browser and internet. No need to download or install because web apps are working with the help of browser and internet. So 2 points are over. Third point.
Excuse me, sir. After because this is working.
One second, I'll repeat. No need to, so no installation is needed. Stop. We don't have to download or install web apps because it is working with the help of browser and internet. So 2 points over. Then third point. better reach to the audience, better reach to the audience, as it can be accessed from anywhere. It might be Android or iOS. No, right? We will have a browser in both the OS, so directly we can access. So better reach to the audience, better reach to the audience, as it can be accessed from anywhere, as it can be accessed from anywhere. It is always up to date. Last point. It is always up to date. Okay, so now disadvantages of native, disadvantages of mobile web application or web application. Disadvantages of web apps. Point number 1. Web applications or web apps fail to work when you're in offline. Web apps are fail to work when you're in offline. Fail to work when we are in offline. Next, limited number of functionalities. Next point, limited number of functionalities compared to native app. Limited number of functionalities compared to native apps. Third point, it takes longer time to develop. It takes longer time to develop. Last point, security risks. Security risks are involved. Security risks are involved. Security risks are involved. So this is all about hybrid, native, and web apps. One more, last one. I'll give a definition of progressive. Look at here, progressive. See, these are all progressive web apps. Okay, when whatever you're seeing earlier, they have initially developed like this progressive web apps. Okay, when we are using a browser, when we open example, say Forbes, or when we open a Tinder, or when we open OLX, earlier we were getting an option like this. Okay, it is a like a website only. Here, if you see that, I opened Alibaba.com, and when I start using, over the period of time, it will give one pop-up. Add to your home screen. It is giving you one pop-up. When you click on continue, it will come and sit here. See here, but it is actually not installed from your Play Store or App Store. Same way here, make my trip. When you started using, it is giving you one suggestion: add to home screen. Then when you click on add here. Okay, then it will come and sit here, make my trip here. Here it is coming and sitting here. But actually it is not a real-time app which is not installed from the Play Store or from the App Store. It's like a normal one file which is sitting on your mobile home screen. When you delete it, it is not actually deleting from your backend memory. Even it is not even saved in the memory also. When you open it, it will deliver the content through this browser only. With the help of browser only, it will deliver the content. So progressive web apps are the advanced version or extensions of the websites. Extensions of the websites, wherein which we can save on our computer or on our device. We can also use like apps. These progressive web apps are developed using browser APIs. We will have a browsers, right? So browser APIs plus native app, some functionalities. We will also use it to ensure that it will give a native app feeling to the user. It will give a native app feeling to the user. But actually speaking, it is a normal website only. It is a normal website only, but which is wrapped, means which is covered, which is wrapped with extra native functionalities. That's it. Okay, fine then. Now let's take down the notes. Progressive web apps. Progressive web apps. Progressive web apps are the extensions of websites. Progressive web apps are the extensions of the websites that we can save on our computers, that we can save on our computer or mobile devices, that we can save on our computer or mobile devices, and we can use like a app, and we can use like a app, and we can use like a app. Use like a app. Full stop. Progressive web apps uses the web browser APIs, 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 and some of the functionalities, uses the web browser APIs and functionalities to bring the native app, to bring the native app feeling across the mobile devices, to bring the native app feeling across mobile devices, across mobile devices, across mobile devices. So this is about progressive. Let's not get into advantage, disadvantage. It's not that much important when it comes to our testing real time life cycle. So next concept is Android architecture. When we are developing any application, it might be Android or iOS. So in the interview, they will ask, "Hey, you are a test engineer, so developer is developing an Android application, but do you have a knowledge that how the Android application will be built? So what are all the features are available, or what are all the sections are involved in the Android architecture? Can you please explain?" They will ask. So you should be able to explain the Android architecture. So before we get into the Android architecture, you take down heading Android architecture and write down this diagram. Then we will explain. I'll explain in detail. Android architecture. Whatever you are seeing that app, it is present in the top layer. Whatever you are seeing using your app, it is present in the top layer. Below that, there are sub libraries like Linux kernel is there, sub library is there, application framework is there. Take down this Android architecture diagram, and we will discuss. Let me know once you completed.
Sir, completed.
Completed. Now write down. Android architecture. Android architecture has been divided into four layers. Android architecture has been divided into 4 layers. Under that point number 1, application layer. Application layer. Second one, application framework layer. Application framework layer. Third one is Android runtime environment and core libraries. Android runtime environment and core libraries. And core libraries. Core libraries. Then last one is Linux kernel. Fourth one is Linux kernel. Fourth one is Linux kernel. Then heading, application layer, first one. It is the topmost layer of the Android architecture. It is the topmost layer of the Android architecture. In this layer, we can access all the built-in applications, native apps. In this layer, we can access all the built-in applications, native apps, and third-party apps. Second point, application framework. It's a second layer of the Android architecture. It's a second layer of the Android architecture. Look at here. Assume that here I have an Android OS operating system. Inside that, when I'm developing an app, right? So it will expose all its functionalities to the OS, to this OS operating system. Whatever the libraries I have here. So this has got activation manager, that activity manager, Windows manager, resource manager, content provider, packages, location manager. All the features and libraries will be exposed to the OS operating system. And also it will be using the Java APIs in the backend. So that's why we call it as application framework. And this framework will help us, like will help the OS operating system to have a safe and uniform utilization of our Android device in the back end. Right now, I know, so the terminology you feel it's little different, but no option. You have to remember. Application framework is the second layer of the Android architecture. Second layer of the Android architecture. Second layer of the Android architecture. Full stop. The Android operating system exposes the Android operating system exposes the underlying libraries, underlying underlying libraries and features of the Android device. Features of the Android devices. Features of the Android devices which are using Java APIs, which are using Java APIs in the backend, which are using Java APIs in the backend. Full stop. Hence, we call it as application framework. Hence, we call it as application framework. This framework, this framework will expose us the this framework will expose us the safe and a uniform utilization of Android resources. This framework will expose us the safe and uniform utilization of Android device resources. Safe and uniform utilization of Android device resources. Next, third one, Android runtime and code libraries. It is the heart of Android architecture. It is the heart of Android architecture. It will be creating a virtual environment in the backend. It will be created virtual environment in the backend to support all the Android activities, to support all the Android device activities.
Or can you please repeat?
From which line?
It is the heart of the.
It's a heart of Android architecture. It's a heart of Android architecture. It will create a virtual environment in the backend. It will create a virtual environment in the backend to support all the Android device functionalities. To support all the Android device functionalities. Look at here, if you see in this diagram, when you are using your contact list from this mobile, from your Android mobile, that contact list will come here. There will be a SQLite. Okay, here. Okay, so here, if I talk content provider, it will connect to the content provider. From content provider, it will come to the SQLite. From this, it will display. There will be a memory management driver will be there from the backend. Through that, you will be able to access. When you open any of your mobile app, okay, it will connect to the activity manager. From there, it will come back to the, say, WebKite or say Open GLES and then camera driver. Then you'll be able to open the camera. So this is how in the backend it works. Okay, next heading, Linux kernel. Fourth one, Linux kernel. Linux kernel. It is the main root component of the Android architecture. It is the main root component of the Android architecture. It is a foundational piece. Foundational, Foundational, foundational piece, P PIECE, foundational piece. It is the root component of Android architecture or Android system. Full stop. It is a foundational piece that enables all the functionalities of Android device. Okay, full stop. Look at here. When you're trying to connect Bluetooth, okay, it will come back slowly and it will come back and connect to the Bluetooth driver. Once this driver starts, then only you'll get a Bluetooth ranges. When you want to play some of the music, or when you want to play any of the video through memory management driver and through display driver, you will be able to see that content. Otherwise, that display driver will not work. That display, you'll not be able to see the images. So this is very, very important. This is the last layer of the Android architecture. So this is your Android architecture. If anybody asks in the interview, you just tell. So yes, I have a knowledge on Android architecture, how the layers has been divided, so how each and every layers are connected. And when they ask you to explain, at least some 2 lines you explain what is application layer, framework, and library, and Linux kernel. This is about Android architecture. And the next one is iOS architecture. Just take down this diagram. We will not go for in depth. Nobody will ask. Just take down the iOS architecture diagram and remember the layers.
Done, sir.
Completed? All of you completed? Hello?
Yes, sir.
Yes,
Yes,
sir.
sir.
Completed.
Fine then. So next topic is types of mobile application testing. So that we will discuss in the next class. So next two classes, I will be able to finish the theory part. And then we will start with ADB commands and Android Studio. So next Saturday, Sunday, I'll finish the types of testing. And then after that, so Saujanya will be taking your ADB commands and Android Studio classes. So she will teach you real-time concepts. And then your mobile application testing is over. Let me stop it today. Okay, so what time your mock interview starts? QC 18, right? Okay, let me come back. QC 18,
11 o'clock, sir.
11 o'clock slots. Let me see that whether he has shared the invitations. Oh yeah, we have 11 to till 1:30. 5 members, huh?
3 slots, 5 members, sir. Last slot, 3 members.
Okay, fine then, sure. Thank you all. Bye-bye.